Okay, so we are looking at partial fractions. So previously you would have done adding algebraic fractions, subtracting algebraic fractions and things like that. So you'd have been going from something that looks like this towards something that looks like this. But we need to be able to work the other way. So we've got to break something that looks like this down into partial fractions. Okay, so these are the three kind of main forms. You don't really need to remember them because the more you sort of practice them, the more you'll remember them yourself without kind of having to memorize them. Okay, so I would pause the video and copy these down. I'm going to do 3 videos. One, we're going to look at something kind of like this. The second one, we're going to look at something like this. And the third one, we're going to look at something like this. So I pause them and write them down. So these are the partial fractions, okay, which is what we're aiming for at the end of our question. So your first example is write 2x plus 3 over x plus 1 brackets x plus 2 in partial fractions. Okay, so looking at this, we can see that we've got something that looks like this. Our denominator is squared, so we've got 2 brackets. If it was just written as a quadratic, then you would try to factorise it, okay, before you obviously go to partial fractions. So we've got this form, so this is what we kind of want to write next to it. So we've got 2x plus 3 all over x plus 1 brackets x plus 2. Okay, we can use the identity symbol because it is always equal to some type of fraction where the numerator is a over x plus 1 plus b over x plus 2. We just don't know what a and b are, so that's what we're going to have to figure out to start with. Just because this says plus doesn't mean it can't be subtracted. It's not always going to be a plus. Okay, that's just the general form. If b is negative, then obviously that becomes a minus symbol. Okay, so what we're going to do, like normal addition of algebraic fractions, we're going to make our denominators the same. So on the left hand side, we've got exactly the same. We've got our denominator is x plus 1, x plus 2, identity symbol. Okay, and we're going to make these denominators the same. So we need to multiply this fraction by x plus 2 over x plus 2, and this fraction by x plus 1 over x plus 1. So we end up getting a brackets x plus 2 plus b brackets x plus 1, and the denominators are now the same, which means the denominator is x plus 1, x plus 2. Okay, so your sort of step 1 is to make the denominators the same. Okay, so now we can see they're the same in that fraction. Obviously we've combined that to be one fraction, so those two denominators would have become the same to become a single fraction, and these two denominators are also the same. So our step 2 is we're going to multiply both sides by these denominators because then they're going to disappear. So we're going to get rid of denominators. Okay, so we're going to be left with 2x plus 3 on this side. Identity. My identity symbol should line up. That's going to annoy me. Identity, a, and then our numerator, a brackets x plus 2 plus b brackets x plus 1. Because my denominators are the same on both sides, I've just multiplied by them, so I'm left with those two numerators. Okay, so now what we're going to do is we're going to use values for x. So we're going to substitute in values for x so that we can find the value of a and find the value of b. So I'm going to use when x is equal to minus 1. Now have a think about why I might be using minus 1. Okay, it's nothing to do with this, and it's nothing to do with this. If I substitute negative 1 into here, well, negative 1 plus 1 is 0. So that eliminates the b, which means I can solve this to find a. Okay, so when x is negative 1, we've got 2 lots of negative 1 plus 3 is equal to a times negative 1 plus 2 is 1. Okay, so 2 times negative 1 is negative 2, add 3 is 1, or 1 lot of a is a, so we found that a is equal to 1. Okay, now think about what other value of x I might want to use to get rid of my a term. So when x equals negative 2, okay, I'm going to use negative 2 because negative 2 plus 2 becomes 0, so that gets rid of my a, so then I can solve it for b. So subbing in negative 2, 2 lots of negative 2 plus 3 is equal to, this disappears, so I'm only left with this part. So I've got b brackets negative 2 plus 1 is negative 1. So 2 times 2 times negative 2 is negative 4, add 3 is negative 1, so negative 1 equals negative b, because negative 1 times b is negative b, so that means that b is equal to 1. Okay, but you still haven't finished your question. You need to be fluent, you need to make your answers obvious. So we're going to rewrite it, so 2x plus 3 all over x plus 1, x plus 2 is identity, and then we're going to write this but sub in our values for a and b. So we've got 1 over x plus 1 plus 1 over x plus 2. Okay, so just remember, so I didn't manage to write the steps down, but these are the most important two to remember. So you make the denominators the same first on our algebraic fractions. Step 2 is we get rid of the denominators. Step 3 would be pick values of x to eliminate a and then b, or vice versa. You can do b and then a, it doesn't matter, but you get the gist. And then our step 4 is sub in values for a and b. So we kind of rewrite it in a formal way.